Ready to go.
All right, what up? What up? I'm Austin. I'm here with Eda. We have come up with an informal title of getting started with contract security for not geniuses, aka us. So yeah, just taking someone who has tinkered around with scaffold-eth and kind of got started. Maybe you've gone through the challenges of the speed run. You're kind of looking for next steps. There's a lot of great challenges out there, but I think what we're going to do is just start tinkering with scaffold-eth. We're going to start with a master branch of scaffold-eth, and we're going to throw in some things and bring in some resources. How's it going, Eda? You feel like my brain is mushy because I am sleep deprived. I have a new baby. I'm going to count on Eda for most of the programming here, and I'm going to backseat drive.
I don't have that kind of excuse. So yeah, I can like share my screen and we can kind of go with it. But yeah, I think smart contract security is super interesting too. So I'm pretty excited to see how we can hack the contracts and show where we have all the resources. So why don't I start by sharing my screen?
Sounds good. Yeah, so basically starting with like stock scaffold-eth, you've probably cloned down the repo, you've yarn installed, you've done I probably need to set security here. You've done a yarn chain and a yarn start and a yarn deploy, and you have your temporary smart contract that's deploying to your front end, and we can kind of tinker around with it there. But then it's like, what do you do next? How do you start like learning, kind of the next phase? You know how to build, you kind of understand the syntax, but how do you really start digging in? And of course, this is a deep, deep, deep rabbit hole. We're just at the entrance of the rabbit hole, kind of helping you through. This is smart contract security for not geniuses, or maybe you'll be a genius one day, and yeah, we can sleep on your couch. Okay, here we go. So yeah, looks like you've got it up. You've got your contract there. Is it deploying? Should we make sure that the initial contract is, yeah, you could even change something there. I always add some extra exclamation points and then redeploy it to make sure they show up. That's my
Yeah, I was
feedback
just
loop.
checking. You can see this string, like my VS Code right now, right?
Yep,
It's
yep.
showing the
We've
right
got VS Code.
Awesome.
Yep.
Yeah, so we can building. Well, this is gonna stop, so we can say building stoppable. Just because we're gonna hack the
Yeah,
contract,
yeah,
and
it's
let's
gonna
kind of
be
see.
something that's gonna break. Yeah.
And I have
So,
this
yep, go
scaffolding
ahead.
set up. Yeah, so all I'm gonna do, as you mentioned, just gonna redeploy. We can basically do a yarn deploy.
And that compiles our contract, it deploys it to our local chain, and then it takes the artifacts and it injects them into our front end, and then we can go interact with that smart contract with the browser.
Yeah, I didn't like mention because we had run through, but I do have the yarn chain over here, my local hard hat node, and I did a yarn start, so that has my React app, and this is basically all on my local host at the moment. Just reloading. We have the example UI. As you can see, it's building stoppable apps right now. I think we'll mainly use the debug contracts,
Yeah, I
but
think
these
so.
two are like the two which are kind of the first places you can look into.
Okay, let's just try to set a purpose real quick, just to get a feedback loop going of we're able to edit our contract and use a burner wallet with some funds. This is going to fail on us, right? Because we'll need to grab some funds from the faucet, and now that should go through. Let's see. Okay, cool. So now we've got a feedback loop. We can tinker with our Solidity. So first step for me is usually going to Solidity by example, right? Solidity by example is such a good resource. Let's land here. We're not looking at any of these topics. We're actually scrolling down, right? We're looking for the hacks, right? So one good way to learn about smart contract security is to go through every hack you can get a hold of, and first of all understand it, but second of all try to re-implement it. So maybe let's just start with the very top one and just start tinkering with it, right? There we go. We got reentrancy.
So yeah, as
And
you mentioned, it's super nice because it also explains what happens. But maybe do we just want to like explain through it, like what we're gonna
let's
do,
just
what we're gonna
implement that, the ether store, right? Let's just implement the ether store in your version of scaffold-eth, and then we can tinker with it from there.
Awesome. So I just got that part. I'm gonna change it here. We can just change this to, oops.
Yeah. There we go.
our
Let's just save
contract.
that and deploy it, right? Let's see what, and then we should see that we get an interface. Yeah. Let's see if it compiles and deploys. And then let's just use the interface at first and show what this smart contract is supposed to be doing by, let's deposit some funds, make sure our balance goes up. Let's withdraw some funds, make sure our balance goes down. Basically, it's just a mapping, right? Keeping track of a balance for any given address. You're able to use a payable function to deposit a small amount. Oh, grabbing some, oh, you didn't put anything in the, you'll have to put a, yep, you got it, you're on it.
Yeah,
There we go.
I'm just gonna get a bit more.
$5,555.
Just because we
All
can.
right. So it has a deposit function, withdraw function, balance function. All right, so now let's probably just deposit a little bit. There we go. All right, and now our balance is 10, right? So and that's way, right? If you wanted to do like 0.1 ether, you do a 0.1 and then you take it times 10 to the 18. Yeah. Yeah, you don't think you have that much. Maybe do like 0.1 and then convert it. There we go. And now our balance is a bigger thing, but there's our balance. Yep. So we're able to deposit money in, and it looks like the withdraw doesn't take a parameter. It just lets you withdraw all of it, right? Oh yeah, you should check the balance before you withdraw, just to prove. There we go. It's showing it there, even though it's showing it in the get balance too. And then if we withdraw, I'm assuming the money all comes back out to us. Yep.
Yeah.
Yep. Yep. Okay. So that's how the bank is supposed to work, but we have a fatal flaw in that, right? Should we go look at the smart contract real quick?
Yeah, sure.
We have, yes, here about line 20 is where we're going to really be focusing on, right? When someone tries to withdraw, it gets their balance and makes sure their balance is greater than 0, and then sends them their balance. And then finally on line 23, zeroes out their balance. And the fatal flaw here is that we're sending them something before we're zeroing out that storage location. And we should probably look at the fallback function real quick, right? We almost want to explain fallback functions here. If we, to really explain this, we need to make a fallback function for your contract, and we don't have that right now. So maybe to kind of slowly go into this, let's go back to our front end and let's try to send some money to our contract. And our contract shouldn't accept it, I think. Let's make sure though. So yeah, let's just try, yeah, straight up just grabbing, yep, exactly, the contract address, and then use your little wallet in the top right, the little wallet icon. Oh, this will work too. Let's just use the faucet. Let's try to faucet some funds directly to the contract. Let's see what happens. It should fail on us, right? No fallback or receive function. So a smart contract can have this receive function. Let's throw a receive function in and let's redeploy. And usually I just, I go to Solidity by example and I look for receive, or I think it's fallback.
Yeah.
Yep.
Okay.
Yep.
One thing I wanted to add.
Receive. Yeah, go. Yeah.
Just because we also mentioned bank, and it was like very interesting to me because this is like actually all the code you need to have a bank. Well, the withdraw is flawed, but basically all it does is it's a mapping of addresses to like how much funds that have. And you can send money in. So like my address sends like $10 in, then it just updates my balance in the mapping. So it's actually like a very simple smart contract. I think like when we say bank, it sounds like a bit more complicated and a bit more like lots of code involved, but this is basically like all the function which makes it a bank. So just kind of wanted to add that in there.
It's to build a bank, you need, one developer for a couple of hours.
Yeah.
And then hundreds of hours of lawyers and regulators and guns
and auditors. Yeah.
Yes. Okay, cool. So we've got our bank built. Let's get this fallback function. So I don't actually see the receive function. I think it's just called receive. It's interesting. There's got to be a good receive example on Solidity by example. Solidity by example is such a good resource. Let's see, where is it here?
Maybe receive money.
There really isn't.
A transfer, is it like no?
Yeah, no. We're looking for the receive function. It's strange that he doesn't have that here. He really should have a receive function section of, if I send him that, he'll say it's probably in the fallback. And it does say there's a receive. If you go to the fallback and you go to the top, it talks about how if ether is sent directly to the contract, but no receive function is, it's really weird. There's no receive function in here though. Right? But that's what we want, is the receive function. Okay, I'm going to make a note to send him a message about he should have a receive function section. But let's just go to our smart contract. Let's just type it in. We'll get it. It's just receive. I think you don't even say function, you just say receive. And I think it's because you know how like the constructor works up there. Oh, there's no constructor either. Yep, there we go. EIVE? No, yeah, it is EIVE. It's a tricky one. There we go. And then it's external payable. And it doesn't return anything. Yep. And then let's just leave the code inside the braces empty. And let's see if that deploys. Basically, by having the receive function, now all of a sudden the smart contract should accept ether and it'll execute, but there's nothing to execute. So it's just going to accept the ether and it's going to not do anything, but it's going to accept the ether now. And we could test that by doing that same thing you did where you just tried to faucet some funds to the contract, or you could use your wallet in the top right and send some to it. Either way works. But let's just try to send some money to it, see if it goes. This should work. Okay, cool. So that receive, we just proved to ourselves that we can send money into our contract. So now let's execute some code just real quick. Let's just have a counter that increments every time someone sends some money in. Actually, no, we have a deposit. Never mind. Just call deposit. I was going to try to set it up so some state changed, but it's easy. We have a bank. If you just call the deposit function inside the receive function, then it's going to, I don't know what that was.
When we do a deposit,
the withdraw is not working. Because you've only sent the money
my
in.
Balance.
Yeah. You need to call the deposit. So in the receive function, we just need to call deposit. You'll see it back in the smart contract.
Okay.
Yeah, here, just on line 31 or so, we just need to call deposit. And so anytime anybody sends money into the contract, it's going to execute something, but right now it's not doing anything. We need it to call deposit. So if you send $100 directly to the contract, it will deposit it for you. Does that make sense?
Oh, yes. So we do this.
Yeah. Yep. That's it right there. Yep.
Okay.
Let's try that.
So it's not adding our address. That's the problem.
Right. It's not doing that part where it increments the balances. It's accepting the money, but it's not keeping track of it. And now it's keeping track of it. So now we should be able to, now at this point, we want to do it as us. We don't want to faucet it in. So you'll grab their address, but then you'll go to your wallet in the top right. Oh, you copied your address. You'll want the wallet icon. It's kind of by the connect button over there. Not your, just to the left of that. Right there, that guy.
Oh, okay.
Yep.
Okay.
And you'll paste in the address, but you have yours copied. So you'll need to jump back there and grab their address. So see how we're sending it to ourselves. There we go. It's happening. There we go. And now if we send that, it should deposit it on our behalf.
Yeah.
There we go. So the money goes into the contract, but if we check our balance, it should show that it's also in now. Or yeah, you could withdraw and it would come back out. But let's see. Yeah, there we go. So there's our balance. Okay, so now we're able to send money to the contract and it detects that there's money coming in and it executes some arbitrary code. In this case, it executes a deposit. That was a long kind of tangent, but now that's how we're going to set up our attacker contract. So if we go back to your bank real quick, there we go. And we look at line 20 where it's doing that execution. Now imagine that the message.sender here is another smart contract and you're sending money to that other smart contract. So that trick we just learned is that we can put in a receive function in and it will execute some code. So imagine if on line 20, it does a call to an attacker contract and that attacker contract has a receive function, then it's going to execute something. And if in that receive function, it calls withdraw again, then it will allow you to re-enter the contract. And since the balance hasn't been zeroed out again, it will send you the money a second time. And so I think that's the trick that we're going to use for our attacker contract. So technically you could deploy this to a test net, but I feel like we could probably just paste in the attacker contract too and start building it. Do you want to just like create a new contract here? We'll have to do a couple tricks with the front end and stuff, but I feel like, yeah, if we go back to the reentrancy, yep. And then we probably just grab this attacker contract.
So I could just, or do you want to make like a new contract? Oops, did I add the same one? Because we called it your contract.
Yep. Yep. You wrap that Ether store address in a payable. So right before the semicolon, you do payable open parenthesis, I think. Yeah,
Oh,
right
here.
there. Yep. You just force it to be payable and then a close. That should fix that error.
Okay.
There we go. There we go. Okay, so what does this attacker contract do? It stores a reference to the bank, right? And then it has a fallback function where if money comes in, so it's going to call the fall. Okay, so they're not even using receive, they're just using fallback, which is fine. It's kind of old school. It's better to use receive, I think, but maybe not. This dude's smarter than me, so maybe it's better to use fallback. And what it's doing is checking to see if there's still money in the bank. And if there's money in the bank, then it continues to withdraw, right? So we'll put in 2 Ether and it should, let's see. So then there's an attack, which, what does it do? Requires, okay, so
we
you
should be
send,
sending more than
yeah,
one Ether.
you send 1 ETH into the attack function, and then it sends that 1 ETH into the bank, and then it calls withdraw. And that 1 ETH will come out to us. And when it lands on us, it will call the fallback function again. And if there's any more money in the bank, it will withdraw it. So to set this up, we basically want to deposit a few ETH into the contract, and then we'll have the attacker contract take out all that ETH. It'll steal our ETH from us, right? So let's see. So you might need, you've created 2 contracts in one. I think if you want to duplicate the your contract.sol into a second file, over on the left, if you just like right click on, yeah, let's just duplicate that, or what do you do? Copy paste.
Okay. Yeah, let's do that.
There we go. And then if we have just that guy named attack.sol and have that content down below.
Okay, this is going to be our attack so.
Okay, and then to use that attack.sol, we'll need to add it into the front end. So we'll need to edit the app.jsx to have the attack.sol displayed. So yeah, that should, let's see if that deploys first. Let's do, oh no, you'll need to import, that'll be a trick. You'll need to import the your contract here. Yep. So you'll do like / your contract. Yeah, import, there you go, you got it.
Oh, yeah.
I think that's it. Yep. Yep. Let's see if that compiles. Why
yeah, I think this should be good.
Let's try it.
Yeah, I think it's just the warning should be work.
Please work first try. Oh. Okay, so now our contracts are deployed, but if we go to our front end, it's not going to let us talk to the attack contract. It's only going to let us talk to your contract. So let's go edit our app.jsx to add in the attack contract too. So you go to app. You go to, yeah, React app source app.jsx, and then you search for like the contract component. It'd be like left, it'd be, yeah, it's just like a less than sign. So like the left the left, yeah. Actually, it's right. It's right. Yeah, keep scrolling a little bit farther. Right there.
Oh,
That
here.
contract, let's just
Yes.
copy that and paste one right above it and have it called, or right above it, right below it, doesn't matter, and have it called
Mhm.
attack. And then if you save that, let's go back to our front end. Hopefully we have both of our contracts now in the front end.
Okay. Do we need to define attack
I think
somewhere
that's
or?
it. I think it's all good. I think that's all you have
Okay.
to do. So let's just go to our front. Oh, you don't even need to redeploy, I
Oh,
don't think,
yeah.
but that's fine.
We're
It's
just
okay.
changing the front end.
Ship it,
Okay.
send it. Let's do it. It'll go. Here we go. Let's see if it reloads. We should get a fresh contract address. And then if we scroll down, attack.
Are we deploying the attack contract?
Something's
Because
not
we are
quite
only
right.
deploying your
Oh,
contract,
yeah,
right?
yeah. We need to go to our deployer. You're right. We need to go to our deployer and make sure we're
Mhm.
deploying. So that would be in,
Here,
yeah, hard hat.
hard
Yep.
hat.
Yep, right there. Yep. Now I think normally you would probably duplicate this file and set it up to deploy the other one, but let's just copy and paste line, I don't know, right up there. What happens if we just copy and paste line 20 through 26 and change your contract to attack?
20 to 20, 29
Oh,
too,
yeah.
right? No, oh no,
Yeah,
we don't.
Yeah, that's fine. Yeah.
Okay, I'll just copy this. Then
Right. And so we'll deploy attacker and it will need, or attack, sorry. And it needs an argument, right? It takes in the address from your contract. So you'll uncomment line 34.
Mhm. And this will take in.
Yeah,
Do we
it
have?
takes in, it'll be your contract address, I think.
Mm.
Wait, doesn't it? Yeah, it does. It does, right? Let's look at the contract real quick. The
Yeah.
constructor takes in address. Yeah. So you'll go back there and I think it's just your contract address. You have the your contract object already there. Yep. Delete all that stuff.
Oops.
Oh.
That address. Yeah, I think this should be good.
Okay. Yeah, and you can uncomment line 40. It might throw some weird error on you.
Oh, this is called attack.
Yeah. What was the error that we got there? We might run that again and see. Oh yeah, it was that same thing. It was the thing we fixed. Yep. Okay, cool.
Yeah.
Please work second try. There we go. Okay, so now we have our contract and our attacker deployed, and we have them visible in the front end. So we should be able to see, we should be able to play with everything now. Yeah, there's the attack contract. Perfect. Okay, so what we want to do first is let's use the faucet to deposit 3 ETH into this contract. So if you just copy your contract, nope, it'd be the bank.
Sorry,
yep.
the bank.
And then let's use the wallet. Yep, exactly. Yep. And let's send them, I don't know. Let's see. So it's denominated in ETH, which is kind of hard. If you click the little USD button over on the right and just say 3 ETH. Yeah. There we go. Now let's send that. So $4,000 has been deposited on behalf of other people. Let's imagine these are just regular users using the bank and they've deposited money in. And if we check the balance of the faucet address, we'll see that they have 3 ETH. And so what we need to do now, yeah, you can check it real quick. You go to the wallet and then copy that F39 address. Yep. And if we check their address, they have a big balance, right? Okay, so now we want to steal that money, right? And the way we do it is just send in 1 ETH here. So I think you just hit 1, hit the little green star and hit send. I think it's just going to do everything for us here. Let's see. Yep. Yeah. now we have 4 ETH. Cool. And the bank is empty, right? Okay. And if we go check the balance of the faucet in the bank, it still thinks there's money there. It's still going to say 3 ETH. it still thinks it has 3 ETH because the mapping that it's tracking has 3 ETH, but the money is gone, right? And should we kind of look through how that happened and how we were able to do that? I think it's just maybe one last look at the contract again, the two contracts together. But this is basically like a little playground where you can play around with reentrancy now and really kind of get to know it. And all we did was just go to Solidity by example and copy paste stuff into scaffold-eth.
Yeah, I think maybe the attack contract
yeah.
is where we want to look at first.
Yeah. Well, let's just let's just trace through if we call attack, right? What happens when we call attack? So it starts with, line 24, it makes sure we send in our 1 ETH, we're good. And then line 25, it deposits the 1 ETH, right? And so if we trace that into the store, all it's going to do is call deposit and increment our mapping, right, on line 13. So it just does that real quick, and then it calls withdraw. And then withdraw is where the magic happens. So it calls withdraw, and it checks to make sure that we have something in our balance, which we do. We have 1 ETH, right? The whole contract itself has like 4 or 5, but we only have 1. Okay. And then it tries to send us, right, on line 20, then it sends us the ETH. And that's when our receive function triggers. So if you go back to the attack contract now just received 1 ETH. So line 17 is going to execute because some money came in, right? And it's going to say, hey, is there any money left in the bank on line 18? And there is. So then it's going to call withdraw again. So then if we go back to the bank, we can see that we haven't ever gotten to line 23 yet. We were on line 20, and now we're back on line 16, and we're doing the withdraw again. And it's checking our balance again, and it hasn't been zeroed out. So it's good to go. And it's going to send us another ETH, right? And then it's going to land in the fallback, basically getting in a loop and looping over any ETH that's left and withdrawing it until it gets to the point where the bank is empty. And then that if statement on line 18 is false, and it then finally subtracts 1 from our balance or whatever it does in the bank. But that's how we're able to steal the extra ETH out of there. I don't know if my sleep deprived brain is explaining it quite consumably, but hopefully that's okay.
I think that was really good. So it's because this contract is like because of the different account types, or because this is like a smart contract account, you can execute a function inside it.
The fallback,
right?
Yep,
like
exactly.
Yes.
When it receives ETH, when an externally owned account receives ETH, it just receives the ETH, right? But when a contract receives ETH, it actually has the ability to execute some code using this fallback function. And that's the trick here, is that you withdraw, and when you withdraw, it's able to execute some extra code and call withdraw again, and kind of do that in a loop, withdrawing as much as it can.
Yeah, and I guess the solution would be like obviously to update the balance before.
Yes, let's do that. Yeah. So let's move that. Let's do it and make sure that we can't attack anymore. Yep. So let's put that, right there. That's the solution, basically. So you create some temporary variable balance, you zero out their current balance, and then you send them. So you want to do state changes first and then external calls second. And so now let's go ahead and deploy it. And let's faucet some ETH in there, right? Maybe faucet 3 ETH into the bank.
Okay, it's deployed. This is your contract is the bank. I'm gonna send. Let's send 3 ETH.
Okay, so nice. There's money to be stolen, basically. And then let's try to attack it with just 1 ETH over here, right? Failed to send
because
either.
We don't have any gas
it should
money.
Send it in. As long as our but if no, it takes it in.
Because we didn't.
No, the attack function takes the money in. It's basically failing to. What it's doing is the fallback is executing. It's noticing that the bank still has money in it, and it's trying to withdraw again, and it's telling us, no, you can't withdraw because you've already withdrawn. So basically it's blocking the reentrancy, or it's fixing the reentrancy problem. So it worked.
Okay, I thought we would still be able to send one ETH, but then
Yeah, you
because of
could,
the
but then
order.
so we have to go back to our attacker contract, and we'd have to comment out the part where it tries to attack it. Because when it's trying to do
Okay,
that second attack, then it's causing the problem to happen.
okay. Yeah, but we were able to not have it be attackable after
Right,
the small
exactly.
fix.
Exactly. Yeah. And okay, so that's kind of what we're trying to show off here, is like an introduction to thinking more about smart contract security. You'll want to go through all of these hacks on Solidity by example. You want to reproduce them like we did here. You want to really understand them deeply. If you don't understand it, go watch a few more videos and go look around. Then you'll want to start looking at like actual attacks that have happened and reading about attacks. And then it's on to some of these other challenges, right? I think the Ethernaut is such a great one here. You've gone through this, right? How has it been for you? What's your experience?
I would totally recommend doing like the Ethernet challenges. There's quite a few challenges. Basically, you sign in with your wallet, and then at each step, you kind of unlock, like you hack the smart contract, and then in some of those, you need to like create a new smart contract, and some of those you just like make some changes from the console directly. But it's really fun to go through, and there's a lot of like different attacks which you kind of reproduce.
That's awesome.
And
And yeah, and it's like tech. I remember that when I got the Ethernet to work, you get like all these celebration in the console, and just like
yeah,
celebrating. I remember that like 5 years ago doing that. It was so much fun.
yeah, there's a lot of nice console like messages like you passed, congrats.
Yeah.
And then this
Damn
is also a pretty
vulnerable
cool one.
DeFi. Yeah, nice. Yeah.
Um,
So this is more like on the DeFi side. It's less like general Solidity bugs and more like deep into the DeFi side of where things can be vulnerable. That's cool.
yeah, another place like for all things smart contract security. But yeah, I think these two resources are pretty cool to get started.
Awesome. Okay, and there's always like other CTFs and EVM challenges going on. Keep an eye on Twitter, follow EVM people, follow builders, and watch for their tweets, because there's always a good CTF. Paradigm does a CTF. They also did the Monaco game. So many fun little EVM games and gas golfing games. So if you're interested in kind of taking your Solidity to the next level, being part of crypto Twitter and just paying more attention to the nerds and seeing what they're building is part of it, right? And re-implementing it locally. One thing we didn't mention that I wanted to mention is the yarn fork thing. With scaffold-eth, you can do a yarn fork. Instead of doing yarn chain and running your chain, you can do a yarn fork, and then all of a sudden your local chain is now mainnet. So if you wanted to test to see if some mainnet contract was vulnerable to reentrancy, you could do a yarn fork, and you could deploy your attacker contract, and you could have your attacker contract try to attack that mainnet contract and see if it works. And that's probably a security demo for another day, but I wanted to mention like yarn fork is another really handy thing for early kind of Solidity security learning. So yes, Solidity security for not geniuses. We did it.
This can be a series, yeah.
Yes, part 1.
Yeah.
Awesome. Thanks, Eda. This was a lot of fun. All right, see you later. Have a good one.
Bye, everyone.